Hello everyone. So now we will solve the fourth problem. Consider flow over the over a wedge where I will I am making a video on we have to start from the boundary layer equations and derive the ordinary differential equations along with the boundary conditions f0 is equal to f dash 0 is equal to 0, f dash theta tend to infinity is equal to 1. Here are the parameters. M is equal to beta pi minus beta, where a beta is the half angle of the wedge. So okay, okay, let's start. So yeah, let's start. Let me make this full screen and we can start. Yeah, I am audible or visible. Okay, may I? So we have to 1 minute. Yeah, okay. So okay, so we have the wedge. We have the wedge which has an angle of we have the wedge which is an angle of beta, and the flow is coming like this. Flow is coming like this, and yeah, and it is going like this, like this. Okay, okay. So we can write as here u infinity. Okay, so this is beta, this is pi minus beta. Okay, okay. Here we will say that this line, assume it as theta is equal to 0. Okay, theta 0 and theta is equal to pi minus b. ठीक है, थीटा इज इक्वल टू 0 लाइन है. ओके, एंड इसको मान here we take this as x. ठीक है, this as y. Okay, and polar coordinates. So phi equal to 0. This is why we are seeing the potential flow solution. It is incompressible 2D flow. So here, okay, so mu theta is equal to 0 at theta is equal to 0 pi minus beta. Okay, why? As it is a uh, surface, so the mu has to be 0, right? And we can say that mu r is equal to del phi by del r, and mu theta is equal to 1 by r xi phi by xi theta. Okay, all right. Okay, nice. So this is like this, and now we start. So we know that del 2 phi is equal to 0, so we can write that 1 by r del by del r del phi by wait a minute, r del phi by del r plus del 2 phi by del theta square equal to 0. Here 1 by r square is coming because it 1 by r. When we solve this, here we uh, here we put r square there, and we got r del by del r del phi by del r plus del 2 phi by del theta square is equal to 0. Cool. Now we assume phi to be phi to be phi to be r r and theta. Okay, now we put this in the equation, so finally we get uh yeah, r del by del r del by del r phi plus put this equation del by del theta square r phi is equal to 0. Okay, so here it is of function of r, here it is a function of theta, so they must be equal to some constant k square or lambda square with lambda square, still lambda square. Okay, so let me take the thing one by one. So r d by dr r dr by dr minus lambda square r is equal to 0. R square d2 r by dr square plus r dr by dr lambda square r is equal to 0. So r is equal to c1 r to the power lambda, c2 r to the power minus lambda. This is a differential equation we are solving. So here we sit here we put ct is equal to 0 for avoiding diversion, avoiding uh, diversion solution, for avoiding diverging solution, and we get r is equal to c1 r to the power lambda 1. Now if we took the second case, okay, if we took the second case, the del 2 phi dr square plus the square phi is equal to theta, sorry, 0. So phi is equal to a cos lambda theta plus b sin lambda theta, and theta is equal to 0, mu theta is equal to 0. So del mu del theta is equal to 0, means b is equal to 0. Why? As cosine function satisfy the boundary conditions, as cosine function satisfy the boundary condition. So as we put b is equal to 0, we get the cosine a function, and this will satisfy the boundary condition we take here mu is equal to 0 at theta is equal to 0 or and y minus beta. Okay. Okay, so yeah, this is all about this. Now 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 we have the solution. We will merge the two solution. Okay. Okay, let me merge the two solution. We get y is equal to c1 r power lambda cos lambda theta. Okay, so we know that mu theta is equal to 1 by r del phi by del theta is equal to minus lambda c lambda to the power r minus r to the power lambda minus 1 sin lambda theta. So at theta is equal to pi minus beta, mu theta is equal to 0. We have the boundary condition, so we apply this boundary condition here. So we can write that sine lambda pi minus beta is equal to 0, lambda pi minus beta is equal to pi. So lambda is equal to pi by pi minus beta. Okay. Now if we see the okay. Hmm. Mu r is equal to del phi by del r. We know that c1 lambda r to the power lambda minus 1 cos lambda theta at theta is equal to 0. Mu r is equal to mu infinity x equal to c1 lambda x to the power lambda minus 1 and mu infinity x equal to a to the power x to the power m, where m is equal to lambda minus 1. Now again now uh, we have the we have the boundary layer equations as what? Mu del mu by del x plus b del mu by del y equal to minus 1 by rho del p by del x plus 2 mu by del y square. Okay, and we know that phi allow us to satisfy the the allow us the satisfy the continuity equation. So as y tending to infinity, we again say that as y tending to infinity, mu tending to mu infinity, and del mu by del y is equal to 0. So del 2 mu by del y square is equal to 0. So we can say that mu infinity d mu infinity by dx equal to minus 1 by rho dv by dx. So that from that we can say that phi is equal to mu infinity x xi x f eta. Okay, zoom slightly. Okay, Okay, where xi is equal to y by xi x. So mu is equal to del phi by del y is equal to minus del phi by x, and mu is equal to mu infinity f dash. We know that now f dash is equal to mu by mu infinity. You remember the case of this? Understand? Why we are taking f dash? We are interchanging the f and f dash from the previous video. So here we are writing this as f dash. So uh, we get v as if we differentiate this with respect to s del phi by del x. If we differentiate is we get minus eta f dash mu infinity d xi by dx plus f d by dx of mu infinity zeta, and we get del mu by del x equal to d mu infinity by dx f dash plus mu infinity f double dash minus eta by xi d xi by dx. ठीक है, del mu by del y equal to mu infinity f double dash 1 by zeta del 2 mu by del y square equal to mu infinity f triple dash 1 by zeta square. When we put all of this in the equation, we get what we get. Yeah, we get, okay, we get mu infinity d mu infinity by dx f dash square, uh, okay, minus mu infinity by xi d by dx mu infinity xi f f double dash equal to mu infinity d mu infinity by dx plus xi mu infinity f double dash 1 by xi square 1 by f triple dash. Yeah, okay. So after solving all of this, we get f triple dash plus alpha 1 f double dash plus alpha 2 1 minus f uh, f dash square equal to 0, where lambda 1 is equal to xi by v eta d by dx mu infinity xi, and lambda 2 is equal to xi square by eta d infinity by dx. So after solving all of this, uh, we get the final solution as f triple dash plus f dash plus 2m by m plus 1 1 minus f dash square is equal to 0. And we are able to derive the equation. And now let me close the video.